Yeah, welcome back to very short video. This video we will talk about or walk through the compiling of Microsoft Phi 2 on the, of course, Tenstorrent hardware and also always with Koyeb cloud. So I'm already edit the starter template, which is the TT transformers. Let's I already in fact have pushed the changes to my cloned forked repository, which is just to take these notes I mean it's not completed, but let's take a look on how it will be if you are working or already working or want to work on such model, LLM model. So it may be take to take a notes on how it will be. Anyway, let's refresh. And where is it? Anyway, it's not complete as I said. It's in the code. I'm in the code step. Just because it's quite stuck right now. So as you can see here, it's stuck. So I record. I think to record short video to show the progress. Not only to show the progress, but to anyway, this is the model. I have let's start with populating the safe tensors parameters. Yes, which was already edits is of course TT directory. Loading checkpoints. Here's I have this you can see here final norm. It was norm, just norm, but because if I to have final iron, which is equivalent of norm, which is the final layer to be, I think, to the all the block transformer block input iron and post attention. I I didn't change it. I know this because although it's not in exists in Phi 2, which I am already replaced with dummy weights, so has no sense this edits or not. Input line are the same, self attention Q and K QKV also are the same. Here's the O weights which replaced with dense, thus doesn't have the same names. Concern the MLP, most of models has three weights, but Phi the micro models like QWin and Phi 2 are small somehow. Anyway, Phi 2 have only two layers, which is FC1 and FC2. equivalent of up and down, I think. Replace this values, this parameters. Also, I think that's all concerning the safe on source parameters concerned. Also, I have edit the MLP because it have only 2 layers. I have updated as much as existing parameters. So there are now, as you can see, there are now up weights projection. I think now only you have 2 parameters. I mean, yes, 2 parameters. I mean 2 weights. So it's pretty clear. I followed this. I think I followed the standard phi for casual LLM how to implement the MLP. It's pretty clear and pretty simple. Anyway, I just you can see just make a linear with the FC1. With the FC2. So because there are no third weights or third parameters, as you can see here, I now need to the W3 output. Anyway, here the W2 in replaced with W1 out. So because no need to multiplication, because you have only 2 layers, if I can say. Then linear, as I said, with itself. This is the MLP. So I have edited so the MLP, to summarize or briefly, is linear between the 2 parameters, the existing 2 parameters, FC1 and FC2. That's all. Pretty simple, pretty clear. Also, we have concerning the rotational embedding. I have to preserve the existing llama function which splits the QKV heads. So just because now at compatibility between shapes, I have padded the cos and sinus matrices to fill in. I add depends on type, cos or sinus. Anyway, pad with the depends to have no, I mean this padding to have not any impact to the final result, just to meet the shape requirements. As you can see here, I pad about 16, yes, from 18 to 96, from 80 to 96, yes. Just add about 16, padded with 16 case, I think, or whatever. Anyway, this is what I'm talking about. So to be ready for the attention, which I split to, always we are on the prefill step, you know. as I said, we paid the cause rotational matrices, which is cause and sines, to be ready for the llama. The existing pre-built function for rotational embedding, and also for the QKV splitting QKV heads. So instead creating a new one, so this such sampler comes with the pre-built function, so which is the compilation of any LLM models. So instead creating a new one and new program config and CPP and whatever, just adopt or the existing shapes with the required shapes to works fine. Also, I mean optimize computation, yes. So here yes, prefer. Anyway, I don't have issue with grids. Yes. Embedding is, as I said, then splitting, then the sdpa, which is require the same requirements as rotational embedding in terms of tensor shapes. Just small issue here, the reshape not works here, which I add this I mean only shows the 80 I mean the as a last dimension, I mean instead 96 to be compatible, I mean to work. Also to be ready, I mean to the concatenating heads without any problems. Also concatenating heads, which I think outputs pretty long tensor, which I split only what I need, which is required for the linear itself, required to be I mean the width of, I think, the first input tensors to be equal to the high second tensor, which is the dense here, the dense widths. Anyway, this is all just mathematical multiplication, and everything works fine. I mean we finished the previous step. That's just want to that's what I want to show. Thanks for watching, and see you. I mean it's May upload another video showing the working, I mean this example. I mean live demo. It may also it may be another video about the decode step, which I'm already working on. I mean, I'm almost finished. Also, live proof of concept or live demo video of working. I will also that's all. Thanks for watching. See you again.